Measures of variation. In this lesson, we'll learn to use measures of variation to compare data. In Chapter 6, we learned that the mean, median, and mode indicate the center of the set of data. That's why we call them the measures of central tendency. And as a review, we know that for a fact that when you talk about the mean is basically adding up your set of data and dividing it by the number of data there are in the set. So, for example, if you have five numbers, 1, 2, 3, 4, and 5, that's your set of data. And you simply add all of them, okay, and divide that by 5, and that's how you get your mean. The median is just the middle. So again, going back to our set, 1, 2, 3, 4, and 5. 3 will be the median because that's the middle of the set. And finally, the mode, let's say you have now 1, 2, 2, 3, 4, and 5. The mode would be 2 because the mode is the one that appears most often in the set of data. And that's just a short review of measures of central tendency, or mean, median, and mode. Okay, but sometimes measures of center don't fully describe the set. The back-to-back stem and leaf plot of a bicycle helmet price is at the right. Both models have the same mean price, the same median price, and the same mode price. But it's easy to see that all prices are not the same. You can describe the set, or you can describe the two lists of helmet prices more accurately by using measures of variation to describe the spread of each set of data. So from this sentence alone, you can now distinguish what measures of variation mean in comparison with measures of central tendency. So in this case, when you talk about measures of variation, it talks about the spread of each set of data, or how close the data is to each other. Okay, and let's talk about it some more. And let's look at the first one. The first definition that we're going to discuss is what we call the range. Okay, definition of the range. The range of a set of numbers is the difference between the least and the greatest number in the set. So when you say range, okay, the range of your set of data will be equal to your greatest value minus your least value. Okay, so it is the difference between the least and the greatest number in the set. So let's take a look at example number 1. Determine the range of each set of data. In letter A, you have 12, 17, 16, 23, 14, 18, 11, and 21. We know that our least value is 11, and our greatest value is 24. Okay, so if that's the case, to be able to find our range, we simply, okay, subtract 23 minus 11, or 12. So the range of this set of data is 12. In letter B, you have a line plot. And in our line plot, again, we find our greatest value and least value. We know for a fact that this is our greatest value, 19, and our least value is 12. So to be able to find the range of this set of data, all we need to do is get our greatest value and deduct the least value, which will give us 7. So the range of our line plot is 7. Okay? Now, next few definitions. So if we have a large set of data, it is helpful to separate the data into 4 equal parts called quartiles. Recall that the median of a set of data separates the data in half. The median of the lower half of the set of data is called the lower quartile and is indicated by LQ. Likewise, the median of the upper half of data is called the upper quartile and is indicated by UQ. Okay, quartiles are used in another measure of variation called the interquartile range, and for our purposes, we will indicate interquartile range as IQR. Again, okay, quartiles, it separates the data into 4 equal parts. So that means each quartile has 25% of the set of data. How does this work? Let's find out. The definition of an interquartile range would be the difference between the upper quartile minus the lower quartile, and we'll talk about that as we go through the examples. So it is the range of the middle half of a set of numbers, and in order to find that, follow the formula for interquartile range, which is now UQ minus LQ will give you IQR. Let's see how that works. In the 13 Summer Olympic Games from 1948 to 1996, athletes from the United States earned the following numbers of gold medals. So at 1948, you have 38, 1952, 50, all the way to 1996, which is 44 medals. Okay, it is very interesting to note that in 1980, okay, the United States have 0 medals. And look at 1984. In 1984, we had 83 medals. Okay, this is the time that in 1980 the United States boycotted the Moscow Olympics, and in 1984 the Eastern Bloc countries boycotted the Olympics here in the United States. Okay, so that's the discrepancy between those two numbers, and that's the reason for those. Okay, we'll talk about that later. Now let's find the range and the interquartile range for the number of gold medals, and let's see how that works. So first things first, list the data from least to greatest. We want to get these numbers to the bottom, and we want to list them from the least to greatest, and then find the median. After you list them from least to greatest, we want to find the median. So let's list them first from least to greatest, and these are the numbers from least to greatest. 0 is the least number, and the highest number is 83. Again, we are using data from this table right there. Okay, and let's find the median. The median, if you recall, is the middle of the set of data. So in this case, our median is 36 because 36 is in the middle of our set of data. Okay. Now that we know what the median is, we can divide the set of data into the upper half and the lower half. Okay, so basically what happens now is that from 37 to 83, this is our upper half. Okay, this is our upper half, and from 36 all the way down to 0 will be our lower half. Okay, going back to the definition, our upper quartile is the median of the upper half, our lower quartile is the median of the lower half. Okay, and we're asked to find the interquartile range, and this is what we do. The upper quartile is the median of the upper half, and the lower quartile is the median of the lower half. So what does that mean? Okay, first, okay, let's look at our median, which is 36. Okay, and then we look at now our upper quartile. Remember, the upper quartile is the median of the upper half. If that's our upper half, the median would be right about here. Okay, and since we have an even set of data, what we do is we add the middle two numbers and divide it by 2. So our upper quartile is 42. In the same manner, to be able to find our lower quartile, we need to find the median of the lower half. And since, again, we have an even set of data, okay, which is 6 pieces, okay, the median will be the average of 33 and 34. So our lower quartile would be 33.5, because when you add 33 plus 34 and divide that by 2, you'll get 2. We now have our lower quartile, we have our upper quartile, and to be able to find our interquartile range, we simply subtract 33.5 from 42, and the interquartile range is 8.5. Okay, for this example. Okay, letter B, which measure variation better summarizes the performance of United States athletes, the range or the interquartile range? Okay, now again, remember I told you that it's interesting to note in 1980 and 1984, okay, were spikes in gold medals. In 1980, there was a huge spike going down. In 1984, there's a huge spike going up in these 2 years. So if we use the range, okay, that would not be very representative of our set. So, since the range represents the values for the years in which the Summer Olympics were boycotted, the interquartile range is more representative of the variability of this set of data. So for this set of data, the interquartile range represents this data better than the range simply because of these two spikes, 1980 and 1984. Okay? Just take a look at the next example. Oh, we're done. So after listening to this lesson, in Google Forms, type a summary of what you've learned by responding to the objective and type a question you might want to ask in class about this lesson. Thank you.